Year-end space and shape review. Here we go. Which transformation is a slide along a straight line? Slide along a straight line is a translation. A. Number 2, which of the following is most accurately describes the translation? Oh, wow, there you go. A, slide along a straight line. B, which of the following most accurately describes a rotation? So rotation is, if we were to rotate our paper, it's a turn around a fixed point. So that would be A. Slide along a straight line, we know that's a translation. A mirror image, that's a reflection. An enlargement or reduction is not either of those. Bonnie is given the ordered pairs 2, 2, 2 and 5, 4 and 5, 4 and 2. What shape do these ordered pairs create? Now again, we could assume that we know what it is because it's one of these. Easiest way to do this is to find a Cartesian plane within your test and to just plot the points. So 2, 2. So 2, 2 is here. 2, 5, 2, 5. 4, 5, 4, 5, and 4, 2. So it makes a rectangle. So B. No, A. Andy is given the ordered pair. So again, we do that thing. What do they have in common? 2, 5, 3, 10, 4, 15, 4, 5. Well, they're all, let's see. When the x coordinate decreases by 1, the y coordinate increases by 5. No. Because if the x decreases by 1, there's no increase there. It also decreases by 5. When it increases by 1, yes, it increases by 5, 5 to 10. There we go, B. Identify the following transformation. So we have an arrow, then an arrow. So this could be, if I put my finger there, that's just a rotation. So again, the orientation of it changes. That's a rotation. Identify the following. This one, if you look carefully at this one is a reflection. Line of reflection there. It's just the mirror image of it there. So C. From the origin, where would you move to plot the ordered pair? 4, 0. So we're starting in the origin. X happens first. So I would move 4 to the right. B. So 0 and 4. So we could look at this one here and see that. So if I'm at the origin, 4 and 0 is right here. So I move 4 to the right. What are the signs of the coordinates in quadrant 1? So quadrant 1, if you remember, is positive, positive. D. Signs for quadrant 4. So that's over here. So we're positive, negative. Positive, negative, C. Quadrant has the coordinates negative 6 and 5. So we've got a negative and a positive. Negative, positive. Quadrant 2, B. Which point on the coordinate grid has a coordinate of 2 and negative 1? So 2, negative 1 is D. What are the horizontal movements from point A, which is here, to point C, which is over here? So horizontal first, 1, 2, 3, 1, 2, 3. So 3 right, 3 up, A. Ken wants to cover his parallelogram backyard with turf. Parallelogram is a base of 16 meters, a height of 10. Turf costs this much. Okay, so we're doing area of a parallelogram. So our formula is area equals base times height. Base 16, height 10. Okay, so 16 times 10. So that's 160 meters squared. And this says it's $5 per. So then we just multiply 160 times 5, $800. D. What's the formula for every parallelogram? Ooh, we should have had that one first. I just showed it there. Base times height, A. So calculate the area of this parallelogram. So just a reminder, see this one has 3. I only need 2 numbers. So height is calculated perpendicular to the base. This is nothing. That's just a distractor. Okay, so we're going to have area equals base times height. So we're going to have 8 times 5, which is 40. So that's C. Okay, next page. Slide that down. Area of a triangle. Formula for area of a triangle. Remember, a triangle is half of a parallelogram, so we just divide our parallelogram formula in half. Okay, so we've got a base of 12 and a height of 9. So you got base of 12 times 9 divided by 2. So we'll do that on a calculator here. 12 times 9 equals, divided by 2 equals 54 centimeters squared, A. All right, we've got a few sets of lines here. Which pair are parallels? Remember, parallel are two lines that do not intersect. They're continuous, they will never intersect. The distance between them is the same. So when you look at these, intersect, distance not the same between, distance between these is the same. The one thing we can also remember for the labeling for a parallel lines is these arrows. Okay, so that is B. Now, which are perpendicular? Remember, perpendicular means intersects at 90 degrees. So this one has the 90-degree box, intersects, no intersection, no intersection. This one just intersects, but at an angle, 90 degrees. So that's part C. Next page. Okay, perpendicular bisector. So remember, a perpendicular we've got, that's 90 degrees. Bisector means it takes a line segment and divides it evenly into two equal segments. Okay, so this one divides it, but they're not equal, these two new segments here. This one just not at 90 degrees, so it's not perpendicular. This one, that's the symbols for parallel. This one is perpendicular, 90 degrees, and then these two hash marks here say this segment and this segment are the same. So the answer for that one is A. Angle bisector, same thing, takes an angle, divides it, and creates two new equal angles. So this bisector, if it were to continue on this side, we would say it bisects. Now this one theoretically doesn't exactly bisect that. If we could measure it, we would, but there's no symboling or labeling on it. Same here, same here. The labeling for this one does cut it in half. This one cuts this outside one in half as well, but this one has the labeling, so we'll say D. Okay, an unknown angle is bisected. So let's just draw a picture. Let's say it's 90 degrees. Okay, so they bisect it, meaning it's cut in half. So now this is 45. Oh wait, this one already has numbers for us. Okay, ignore what I did there. One of the resulting angles is then bisected again, so then they cut this one in half here. If the measure of the angles resulting from the second bisection, that's this one, is 17, so meaning they're both 17 in there, what is the measure of the original? So we have 17 on the second bisection, 17, 17, so 17, 17 is 34. So these two over here, because it was originally done as a bisector, so 34 and then 34, so that is 68 degrees, D. The two new angles created by drawing an angle bisector are equal, correct, are greater than 90. No, these ones aren't at all. Are less than 90, well it was this time, but it doesn't have to be. Equal 90, no, A, are equal. The two new angles created by an angle bisector, by a perpendicular bisector, the two new angles. So it's perpendicular equal 90. D. What is being constructed in this diagram? So again, here we have a line segment. We see the hash marks. We see the perpendicular line. So this is a perpendicular bisector, which is D. An obtuse angle is, so flashback to grade 6 here, greater than 90, C. Not equal, not equal, not less than 90. What is being constructed in this one? So again, we've got a compass here, we've got an angle. So the only one we've got here, we've got angle bisector, congruent line. We don't talk about congruence in grade 7. Parallel lines, no, those lines intersect. Perpendicular, that's not a 90-degree angle, so A, just by a process of elimination. But remember, this is them showing how we mark that. You put there, mark that, then you draw that line straight through there to bisect that angle. A parallelogram and a triangle have the same base and the same height measurements. What do you know about the area? So remember what we talked about, the relationship between a triangle and a parallelogram. A triangle is half the size of a parallelogram. So if they have the same base heights, the triangle still will have half the area of the parallelogram. The area of the triangle is half the area of the oh, it's right there, A, easy. Area is twice the area of the parallelogram, no, because it's smaller. The areas of the shape are the same, no. The areas of the two shapes are unrelated, no. A parallelogram, they have the same perimeter. What do you know about the areas of these two shapes? The same perimeter. The perimeter tells you nothing about the areas of this two shapes. D. We don't worry about perimeter when we're calculating the area. A parallelogram has a height of 2.4 meters and an area of 1.68 meters squared. What's the base? Okay, so we're working a little backwards on this one. So remember, parallelogram area equals base times height. And on this one, we know the area is 1.68 meters squared equals, we know the height, so it's going to be 2.4 b. So this is a one-step equation, which we can do. So divide this by 2.4, gets rid of that. Divide by 2.4. Okay, so 1.68 divided by 2.4 equals 0.7. So then the base equals 0.7 meters. Okay. 31, which one of the following words describes the distance around a circle? So a distance around a circle is going to be the circumference. Area is the space it takes up. Diameter is the distance across the circle through the middle. And then radius is from the center to any outside edge. Which of the following calculations is the diameter of a circle equal to? So D equals, so we know that it's twice the radius. Double the radius, yes. Half the area, no. Half the circumference, no. The circumference, no. So it's A. The circumference is approximately 3 times its diameter. So remember, circumference equals pi times D, or C equals 2 times pi times R. Okay, so 3 times. So this is like an approximate. So this is 3.14, so that's there. 3 times what is the circumference? Diameter, C. Which of the following is the best option represented by the values circumference divided by diameter? Okay, so I have this, and I divide this by the diameter, and I divide this by the diameter. What does that equal? Pi. That's all you're doing there. Even if you, this one, if you wanted to take an example, say it's whatever, say the diameter of a circle is 3, okay? So circumference equals pi times D. So you'd have 3.14 times 3. The circumference would be 3.14 times 3. So you'd have 9.42 as your circumference. If I was to divide the circumference by the diameter, which is divided by 3, it's going to give me pi. If a circle has a diameter of 52, what is the approximate circumference? Okay, we'll do that one down here. Okay, so C equals pi times D, and this says 3.14 times, and that said 52 meters. So then I will take 3.14 times 52 equals 163.28. So the circumference is 163.28 meters. Approximate right there, C. What's the approximate circumference of a circle with a radius of 3.9? Rounded to the nearest hundredth of a meter. Okay, so radius this time. So C equals 2 times pi times R. And the radius they just said was 3.9. So 2 times 3.14 times 3.9. 2 times 3.14. Whoa, back that up. Times 3.9 equals 22.492, and it wants it hundredths. So 24.49 is it properly rounded to hundredths, C. What is the radius of a circle with a circumference measuring? Okay, so we have circumference. Okay, and we're just going to do this one because it's easy. We'll find the diameter, then we'll make it into that. So we know the We know this, 27.004 equals 3.14 times D. So I'm going to divide by 3.14 to get rid of those. Divide by 3.14. Okay, 27.004 divided by 3.14 equals 8.6. So my diameter is 8.6 centimeters. But it wants to know the radius, so I just cut that in half, so it's 4.3. Okay, the radius is equal to half the diameter. So 4.3 is B. Okay, what is the radius of a circle with approximately approximately 200. I'll put that on here so I can draw on here. Okay, so this one, area equals pi times r times r. So this one's a little bit tougher. We don't really go over this kind of stuff, but we'll just do it anyways to show you how I would do it. So that's the area, so it goes there. 3.14 times r times r. Okay, so that's r squared. If you want to write it like that, it might make it easier here. Okay, so I'm going to divide this by 3.14 to get rid of that. Divide by 3.14. Okay, so 200 divided by 3.14 equals 64. 64 equals r squared. So if I do a square root of this to get rid of the squared, and I square root this, 64 square root is 8 equals the radius. So if you want to go back and double check this, you would just put in the 8 for the r. So pi times r times r. 3.14 times 8 will give you 200. So then we look here, and it is B. All right, last question. List 5 capital letters of the alphabet that have identical images after reflection. Now this is a fun question, but depends how you're reflecting. If you're reflecting horizontally or vertically, so vertical, so I do a capital A, looks the same over here. Okay, capital A does. How about like an H? H would look the same over here. And I would. O. What else would? Maybe a T. Maybe a U. A V. What about a W? What about W? What about an X? What about a Y? Okay, those are the main ones I think. Maybe like an M as I think about it more. Let's do a horizontal one. So 5 that are horizontal, meaning this way. Meaning that if I put an O here, an O would look the same in the mirror reflection. A C would. E, wait, back up, an A, no, because A would be upside down. B, yeah, B would. D would. I'll just go in order. Put these out there. How many more can we come up with here? E, F, no. G, no. H, yes. I, yes. J, no. K, yeah, capital would. K, L, no. M, no. N, no. O, we already did. X, yep, X would. Y, and Z. Okay, there we go. Those are the ones. That's an H. There we go. That's the whole test.